although there is absolutely nothing wrong with this, and although the author leads you down that particular path, the vast majority of systems that we have are easier to solve by finding intercepts. The vast majority of problems that we have that we're going to be doing in this section and all the way through are going to have exercises which are set up so that both coefficients will divide that constant and leave you whole numbers. And whole numbers are easier to graph. Intercepts come in two flavors. We have x-intercepts. X-intercept has to lie on the x-axis, and if it lies on the x-axis, then it has to have an x value, but its y value will always be 0. So we're going to find an x-intercept by letting the y value be equal to 0 in the equation and crunching the arithmetic of the problem. Now 0 is not bad, because if we let a y value be equal to 0, what happens when we let this value be equal to 0? It goes away, doesn't it? I mean, 2x is equal to 8, which is almost a problem you can solve without having any paper and pencil work, correct? What happens if I let y equal 0 down here? This goes away too. And it gives us a relatively simple equation to be able to solve. The vast majority of problems that we have are going to be of this particular type, where we will encourage you to find the intercepts because it's quicker, it's more efficient, and you don't make mistakes with, oh, I subtracted where I should have added, or I added two terms together and came up with the wrong answer in the problem. So we also have y-intercepts. Y-intercepts are points that lie on the y-axis. And if it's a y-intercept, then it has to have a y value, but it lets x be equal to 0. So we're going to target finding the intercepts by letting either x equal 0 or y equal 0. And we can do that very efficiently and quickly. So in the top equation, if I let x equal 0, what's going to happen? Okay, so let me ask you this question. Do I really need to show this step? Because you know that 2 times 0 is going to be 0. And you know that 0 added to anything is going to make it go away. So what's the effect of letting x equal 0? It gets rid of the x term completely and loses all the information as a responsibility of y. That partnership of x and y just turned out to be a one-man show because x was on vacation. Y makes all the decisions now. So it's almost something that you could do without having to do all these individual steps. So if x is equal to 0, I should have left that there. If x is equal to 0, I know I'm coming up with a y value that's going to be equal to 8. And that's still the same point that I got by doing the slope-intercept form, isn't it? Okay? If I let y equal 0, then isn't that going to make y go away? And isn't that going to leave 2x is equal to 8? And isn't that going to lead me to an x value of 4? So now my ordered pair is going to be 4, 0. And isn't that the same point? Well, wait a minute, that's not the same point that I put on the graph, is it? One of my points, because you chose an x value of 0, automatically was a y-intercept, which is a good choice. But I would have said, maybe than just vaulting blindly down the line where I said I'm going to do x equal 1, I would have taken the y value equal to 0. And if I did a good job of graphing, tell me what the coordinate of that point looks like. Looks like 4, 0, doesn't it? So I did a pretty good job with graphing, so I'm a little bit happy with my graph in this particular problem. Okay, so if we did that with the x's, we can do the same thing for the y's. So if we come back and we take the y equation in the problem now, if we start by saying that x is equal to 0, don't we know that that's going to make that 4 times the 0 plus, excuse me, minus y? Don't we know that that's going to go away? Don't we know that minus y is going to be equal to 4? And doesn't that force us to accept y then is going to be a negative 4? So wouldn't our ordered pair for this one be, because we let x equal 0, then y turned out to be a negative 4? And isn't that the point that we got anyway? And could we also come back and say we want y to be equal to 0? And if we let y equal 0, then that would mean that 4x is going to be equal to 4. And that means that x is going to be 1. So we end up having a 1, 0. And we just happened to get that point accidentally. And now the question is that we want, what's this point? Now, if I didn't do a good job of hitting those dots right dead center square, then I got a problem. And this line did not hit the dots right dead center square because it doesn't look like this point up here. It doesn't like this point is right at the corner point, or what we call a lattice point. Now, that means it's not necessarily reliable for me. So I want a better technique than graphing. But graphing is a tool that you're going to use. Since graphing is a tool that you're going to use, let's go into the homework set and let's show you one of the places where you will see that graphing type of problem. There are several problems where you will do graphing, but one of the problems is right here. Now, let me offer you a suggestion. When you're